Okay. I'm recording as well.
Okay.
Yeah. So this is topic one. I sent it. I gave you the video for topic one. I don't know if you have gone
Yes.
through it. So today we
Yes.
to topic two, the database and the database management system, or
Okay.
we can call it a DBMS. So this
Mm.
topic covers databases, the types of applications. We'll look at the pre-database information systems, database approach, database management systems, commercial implementations, the relational model, and the alternatives. Relational models and alternatives. Okay, let me just see. Connect the laptop to the power pack.
Mm.
Okay. So the learning outcomes. By the end of this topic, you'll be able to describe the main features of a database system. You'll be able to understand the role of the database management system, describe pre-database information system, identify some of the commercial products available, understand the importance of the relational model, and identify some alternatives to reach. Then what you see there, the screenshot, it's an example of data in Microsoft Access. Data in Microsoft Access. This one shows the example of data in Oracle. By the way, Oracle, it's a type of DBMS. You've got types of DBMS. There's Oracle, there's Microsoft Access, there's MySQL, there's MySQL Server. There are many types of DBMS. So the other one, it's a metadata. Metadata. Metadata, metadata contains a data dictionary. So that's the example of
Mm.
metadata. Hello?
Yes, hello, I can hear you.
Okay. I'm saying this is the example of a metadata, or we can say a data dictionary. It will show, let's say for the table, it will show the name of the attribute, the data type, where it says type, the length, and as well as a description. When we say student name, data type, it's a character, or should we say text. If it was a,
Mm.
then the length could be 50. So what it means that the name of a student, you can't enter a name which will contain more characters, more than 50. So it can be less than 50 or equal to 50. The restriction can't go beyond 50. Then the description, student name, it's a student name because it's the name of a student. Then student ID, the data type is a number because here IDs will be numbers, isn't it? Hello?
Hello.
I'm saying it, data type is a number for student ID, isn't it?
Yes.
Okay. And the length is 8, meaning that the maximum student ID should be 8. Then
Okay.
description, a student ID, it's a unique identification number for a student. Then date of birth, data type, it's a date. Length is 8. Description, date of birth in the format, which is
Okay.
01
Mm.
January 0180. Could be 1980 or something. Okay. Then that's metadata. That's how it will be shown in Microsoft Access. In Microsoft
Mm.
Access, yes. Then that's a metadata in Oracle. It will show the name of the attributes. We've got employee number, name, job, manager, hire date, sales, department number, then and its data type, and its data type. You know what it means by not now? The employee number is written not now, then type it's a number, meaning that employee number, which is a primary key, can never be empty. Okay?
Okay.
In the numbers are created, let's say if you are creating a database for students, first of all, students should be there. That's when you'll be given numbers. As a student, you are not going to find the numbers are already out. That's why it takes maybe a month or two for the student to be given the student number.
Okay.
Yes. You have a student number.
Not you said you check for me, then you update me.
The student number. Since you have
Yes,
written you have written exams before.
yes, I've written exams before.
Yes, meaning that you've got a student number.
Oh, you want that odd one?
Yes, you use that same old one.
Oh, okay, that's okay.
Then metadata is data that is about data. As I said, metadata contains a data dictionary. We know a dictionary contains the everything, the data we are looking for, isn't it? You find it in the dictionary. Then metadata, it's the way in which the database keeps information about its own structure. So the metadata, this is where the database will keep its information about its own structure. It is important in understanding how data can be independent of applications in the database approach. Metadata is stored in the dictionary. Metadata is stored in the data dictionary. In activities define metadata for data about the following. For instance, student in a college database, books in a library system, holidays booked by a person at a workplace. Try to think about what data needs to be kept. Will it be a character? Will it be a date? Or will it be a number? Then what you see there, it's a two-file processing system. A two-file processing system. In fact, that's the structure of a database. It contains what you see on the left, on the right-hand side, like a container. This is where the actual database are being kept. So that's the hardware. Then in between, you've got a customer processing system. This is the system now. Actually, this is a DBMS, okay? This is the DBMS. It could be Oracle. It could be Microsoft Access. You are using maybe Microsoft SQL, MySQL. Then on the left side, where it's written customer file user, this is a software. This is a program written in a programming language, any programming language. So as you are aware, sorry?
Example. Oh.
Let's say a software you're using at work, the system.
Okay. Oh, okay.
So meaning that when you enter the information in that particular system, when you say enter, that information is going to the database, which is in between the DBMS, where it's written the customer processing system.
Okay.
So customer file users, then we have rent file users as well. Then we have the DBMS for rent processing system. Then the actual data is being stored in the hardware. So when the rent file users request for the information through an application form, it goes via the DBMS. In this case, it could be a rental processing system or a customer processing system. Then it retrieves it from those files, customer files and rental files. Are we together?
Yes.
Then let's look at the file processing. File processing systems that are separated and isolated, that are often duplicated. Application programs are dependent on file formats. Files are often incompatible with one another. It's difficult to represent data in users' perspective. Difficult to present data in users' perspective. So what you see there is a basic structure of a database. As you can see, there is DBMS there. DBMS, Database Management System, connected to the actual database, which is looking like a container like. Actually, that's a hardware, that's a hard drive. Then we've got 3 users. We've got 3 users. We've got those in customer, those in
Rental processing
yes.
and the
Those.
other application.
All right. Yeah, that's right. That's right. So all these, as you can see, all these 3 are accessing data from one container, isn't it?
Yes, one
And
source, yeah.
yeah, one source, and the DBMS is the same. As you can see, that's a detailed one. DBMS serves as intermediary between user and the database by translating user requests into the complex code required to fulfill those requests. Then we have, let's look at the customer processing application. It's a two-way. A customer can send an application, can send a request, right, to DBMS.
Yes.
Then DBMS can send back data. Then DBMS, it is getting it from the metadata. Have you seen where there is a metadata?
Yes.
The database itself. So application on the left-hand side are written in programming languages such as Visual Basic, C++, C#, Java, Python, all such things. So it might be created through a DBMS utility, e.g. Microsoft Access. You can create the forms in Access. You know that, huh? Yeah, so you can create like that. Then features of the database approach. In the exam room, if they ask you what are the features of the database approach, make sure that you remember 1, database is a model of a model. Database approach is integrated data. Database systems maintain program data independence. Database systems are self-describing, easier representation of users' perspectives, a program data independence, reduced data duplication. These are the features of database approach. These are the features of database approach. What? Okay. Then we've got common applications. The common application includes the forms. It includes reports. It includes web application. It includes batch processing. Okay, so these are the common applications. We know about forms. You can enter details in the forms, isn't it?
Yes, where you enter names or other characters.
Yes. You can also use the forms. Okay, got to mommy now. You can also use reports. Then we'll use also web applications. You can use also web application environment. Then we have batch processing. Batch processing, it means that data is processed in batches. Let's say when you go to the bank, you deposit a check. You know, one check can't be accessed, not until maybe there are 100, or maybe they are above, or maybe there are 50. It's them to set the batches. Processing one by one, it wouldn't be, maybe they can waste the resources, isn't it? Yes, so you find that they have set the batches.
Okay.
Then DBMS architecture, that's the architecture of a DBMS. There is a kernel, a toolkit, and the interface. So that diagram you see there, you need to know how you can draw that diagram. You need to know how you can draw that diagram. First of all, it's the actual database. Then DBMS kernel sits on the database. By the way, the database is a hardware. That's a hard drive. Then the interface. So the interface is what users use to interact. Okay, just a minute. I just want to answer some coding. Hello? Hello? Connect. Okay. Okay, I'll send you the videos, the recordings. Okay, then make sure you go through the recordings because by next week we have to do some questions. All right. Hello?
Hello.
Oh, okay. So we have the interface, then the DBMS toolkit. Do you still remember the DBMS toolkit? Can you tell me 3 of them? The architecture is the same. The toolkit comes in different forms.
Okay, the toolkit, is it the one which has got in the what? Where
Oracle,
it has got the three sets as well.
it's Oracle, Microsoft Access, MySQL. In short, we are talking about the types of
Okay.
DBMS that can be used. Okay.
Okay, noted.
All right. Then
the interface.
no, the interface, every toolkit comes with the interface. It's like you are saying the phones, they have got different interfaces. There are those which are using Android interface, those which are using iPhone interface, those which are using Nokia, something like that, isn't it? Hello? 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 Okay, so database management system functions. Those are the functions. There is a CRUD functions. There is a data dictionary. There is a transaction management system. There is concurrence control recovery. There is authorization. There is data communication. There is data integrity and administration utility. These are the function of a DBMS, regardless of the which type. It could be Oracle, it could be Microsoft Access, it could be MySQL. Functions will be the same. Then DBMS interfaces functions. There are 4 functions: data definition language, which is short for DDL, data definition language, which is short for DDL, data manipulation language, which is short for DML, data integrity language, DIL, then data control language. So these languages, we use them when we start using the SQL structured query languages. Very soon, we'll start doing the structured query languages, SQLs. SQLs, when you look at your assignment, it comes on task 2. It's a task 2. Okay. Then the advantages of DBMS control, it has control over data redundancy, it has data consistency, more information from the same amount of data, sharing of data, improved data integrity, improved security, and enforcement of standards, and enforcement of the standards, Okay. Then economy of scale, balance of conflicting requirements, improved data accessibility and responsiveness, increased productivity, improved maintenance through data independence, increased concurrence, improved backup and recovery services There are also disadvantages. Most of the things have advantages and disadvantages. Databases have got, DBMS have got higher impact of failure. Then they are very complex. Complexity and size, cost of the DBMS. These DBMS are very expensive. They are not free. Then you need additional hardware costs. Let's say you need to buy maybe servers, database servers, which are not cheap. cost of conversions, as well as performance. Performance varies according to the type of hardware you are buying and also the type of software, maybe versions you are buying. Then market share of commercial products, they're just showing these types of DBMS, how they are used. Like MySQL, 29% are using MySQL, 23% are using Oracle, 24% are using MS Access SQL Server, 10% are using DB2, then 14% they are using other DBMS on the market. Then commercial implementations, Oracle, Microsoft SQL Server, then MySQL. These can be used on a commercial. Maybe smaller organizations are the one that can maybe go for these non-commercial softwares, but you need to purchase Microsoft SQL Server if you want, or Oracle, or if you want MySQL. These two is for Microsoft. Then the data models, we've got hierarchical, we've got network, we've got relational, database models, object-oriented, deductive, and post-relational, data models. Okay, do you have questions?
Not very much. What I wanted to ask is the one that we are from passing. I wanted to compare on the when you go back. What it was slide number what? Where there was next forward.
This one.
Next. On this one, there's the kernel, toolkit, and interface. So I know the kernel. That's like the actual installation on the hardware.
Yes, that's true.
Now the toolkit, and the toolkit comprises of you said the
software. It could be Oracle, it could be DBMS, it could be Oracle, MySQL.
Oh, I see. Okay.
Yes.
Now the interface is like
the form.
The one we know.
Yes, the same.
The one we interact with.
Of course.
The one we interact with.
Yes.
Okay, we can proceed. I want to just to compare. At times you find that the questions come in different ways.
That's true. But you have to know that every DBMS has got its own interface. Yeah. The way we can have Android interface can look different from Microsoft
Apple
interface. Yeah, from Apple interface. Just like that.
Okay.
Yes.
Okay.
Okay. These are the references. You can visit that link, or you can look for a book, Connery T. Baker. I'll give you this book. Remind me. I'll give you. I have this book. Actually, this book is enough.
You have it on PDF?
Yes, I'll send it to you. I have it. Okay. So let's proceed to learning outcome. To topic 3. Okay. Topic 3. Topic 3, we are looking at the entity relationship modeling. So we'll cover the following topic: entity relationship modeling, types of notations, basic concepts, entities, relationships, attributes, and identifying entities. So you'll be able to understand the goal of ERD, recognize different types of notations, understand the concepts of an entity type, relationships, and attributes, then begin to develop an approach to identifying entities. The goal of entity relationship modeling is to produce a model of data and data use that is non-technical and free of ambiguities. Entity relationship modeling, it's a modeling tool. It is not the only modeling tool. There are other modeling tools that you should know. We've got a flow chart. There's a use case. We have the case tools. We have class diagrams and so on. So these are used to model the system when you're developing the system. A model is like you want to build a house. Before you build a house, you need to have a plan, isn't it? If you don't have a plan, meaning that you can't start working. So modeling, the definition of modeling, it's designing before the actual coding. Designing on paper, it's on paper, you design it on paper before the actual coding. Okay, just a minute, I'll be back.
Okay.
Mapara, I want to charge the phone. Where is it? Open the door. Okay. You have done? Okay, wait for me. I'm coming. Okay, are you done? Remove that. Throw it out. Hello?
Hello.
Okay. I was saying there are a lot of modeling tools. ERDs, it's mentioned in the database, or we'll learn about in the database, because ERDs are the establishment of databases. So you can't come up with a database if you don't work on the ERD. So let's look at notation one. It shows the three databases, or three entities, three tables. There's module table, there's student table, and the student on module. Then those are relationships, like where you see 0, 3 dots, and asterisk, it means many. Okay?
Okay. Yeah.
So we can have many to one. Module is one. So we are saying many students can do one module, isn't it? One student can do one module. Then many students can do many to one. We can have many modules, one student, just like yourself. You are doing many courses, isn't it? Then attributes for module, we've got a module code and a module name. Module code is a primary key. A primary key is a unique identification of an object. Do you understand the primary keys, right?
Yes.
Okay, so why is the module code being picked as a primary key instead of module name?
The primary key is a unique key identifier.
Okay, then we've got a student on module, attributes, module code, student number. They are the same with they are the same attributes with the student. But in the student on module, if you look at these, they are all foreign keys because these keys are
Yes.
coming from who? This table is made out of module and the student. No wonder we have module, we have attributes coming from who? Module, which is module code, and the student number from who? Student table. And all of
Yes.
them are foreign keys. All of them
Yes,
are
because
foreign keys.
mm,
Yeah. Then let's look at notation 2, CrossFit. We have module. They are the same modules. They are the same modules. They are the same modules actually. They are the same tables. Then the same primary, so the same attributes as well. Then what you see there is an ERD. It's a notation chain. It's called notation chain. Notation chain.
okay.
The tables are modeled in a rectangle, as you can see for the module. It's in a rectangle. Then attributes are modeled in an oval shape. That's why you see module code in an oval. Then relationships, how to link these two tables, we use a diamond. Okay. So what's the relationship? What's the relationship between a module and a student?
The module and the student is the diamond, the one which is in between.
No, text module, student text module. That's a relationship.
That's the one.
Yeah, no wonder
The
you
one
find.
which is in between.
Yes. So
why
text.
there's like a diamond.
Yes. So the relationship between these two tables, the student takes a course. That's a relationship. So this relationship, you put it in a diamond. A diamond represents a relationship. Then the cardinality, we have where we have M, meaning many. So we have many modules. We have many students taking many modules. If you want, you can have many students. If you want, you can have many students doing one module. It's all the same. Yeah, depending on how you have modeled it. So entity type, it's a group of objects, people, types, concepts, or other items that have the same set of properties, known as attributes. Must be of interest to whoever is building the new information system. Must be of interest to whoever is building the new information system. An entity occurrence, a unique instance of an entity. What the entity does, we call it an occurrence. Then the activity, identify entity types that might exist in a library system. Can you also think of some entity occurrence? Of course. Then look at the library system. Let's say you are building a library system. The first thing that you have to do is to identify how many tables are we going to have in this system, isn't it?
Yes.
So a library system can have a book, a subject, a borrower, a loan, and the author. By the way, these tables that you are going to identify, at the end of the day, they need to be related. When you look at this, to be linked. When you look at these tables, it will be very easy to link them. Why? Because author writes the book, isn't it? The book is written under the subject. Then a book is loaned to a student. Let's say when a student loan a book, you got a loan, that's when the student can borrow a book, as you can see this. So books can be just examples, Lord of the Ring, Introduction to Databases, How to Win Friends and Influence People. These are just book titles.
Yes.
Then these books are in subjects. It could be history, it could be fiction, it could be math, it could be whatsoever. Then entity types. Each entity type is shown as a rectangle labeled with the name of the entity, which is normally a singular noun, like that. An entity should be a singular noun. Then in UML, the name of an entity should begin with the uppercase letter. That's why we've seen a book is not started with a small letter, a B. It's supposed to be a capital letter B. Then relationship types. Relationship types. The meaning for association between entity types. Then the relationship occurrence, the concrete instance of a relationship type. The concrete instance of a relationship type. Then activity. What relationships exist between these entities? We've already mentioned those entities. Look at the relationship. Author writes a book. A book is written under a subject. A book can be loaned to a borrower. A borrower who is a student, isn't it?
A student, yes.
Yes. Then organizing it in better, just looks better. It can look like that. A book is loaned. A loan is given to a borrower, right? Then a book is written by an author. Then the book is written under a certain subject.
Yes.
So that is the hierarchy. Then relationship names. We can have author. Look at that. Look, author writes book. Book classifies subject, isn't it?
Yes.
Book taken out on loan. Loan takes out. Borrower takes out loan, as you can see, according to where the arrow is pointing. Borrower takes out the loan. Okay. Then we have multiplicity. Multiplicity. A number of range of possible occurrences of an entity type in relationship to another entity type. In relationship to another entity type. Okay. Then multiplicity 2 is the same ERD. A book is classified by one subject, but one subject could classify many books. We are saying a book can be written under one subject, right?
Yes.
But a subject can classify many books. Let's say if I write a book in history, it's one title called the history book, right? But you can have many copies of that particular history book. That's what it means.
Oh, I see.
Then the same multiplicity, we talked about the multiplicity. We can have many books, one subject. Have you seen?
Yes.
Okay. Okay. Just a minute. I want to answer this call. Yes, what? Hello?
Yes, boy.
Yes, yes. Eh? Okay. So a book is classified by one subject. Hello? Are you there?
Yes, I'm there.
A book is classified by one subject. So we have many books, one subject. No wonder we have one to many, as you can see. It's written 0, 2 dots, and asterisk. It means many.
Many.
Many, yes. All right. Then the subject classifies a book. That's a relationship. Then a multiplicity.
Is it a bishop?
Multiplicity.
A bishop in the laptop.
No, he's coming. Multiplicity, we have the author writes a book. Book classifies subject. So author and the book, the relationship is many to many. One to one. One to many, actually, for me. One author can write many books, isn't it?
Yes.
So a book is written by one or more authors. One or more authors. An author writes one or more books also. Okay. Then, of course, it's important for self-study. A book is classified by one subject, but one subject could classify many books. Then attributes. what is an attribute? An attribute is a property of an entity, or we can say an attribute belongs to an entity. For instance, if we say a student is going to have attributes like student name, first name, last name, the course they are doing, all those belongs to the student, isn't it?
Yes.
Yes, that's what it means by property of an entity. Then attributes, we have attribute domain, simple attribute, composite attribute, single valued attribute, multi-valued attribute, multi-valued attribute. So activity, what are the attributes for the entities we identified as part of the library system? Like for the book, author, borrower, and the loan. We haven't identified, but we can identify. For instance, a book. A book can have properties like properties or entities like the book title, the book copy, ISBN, isn't it?
Yes.
And the author. Even if author is there as its own table, but it can be there. Then the author can have a name, last name, address, okay, such things. Then borrower, who is a borrower? Borrower is a student. So you just get the student ID as a borrower. Then the book they are borrowing, the duration, how many days are they going to stay with that particular book? So those can be the attributes.
Okay.
Okay, example, identifying the entity. They said look for nouns. This is an example. A student record system is used to allocate students to modules. Each module is part of a course. Each module has one or more assessments attached to it. So what can be the entities from this scenario? How many entities can you come up with?
Three.
Yeah, 3. Course, module, and the student, eh?
Yes.
Yeah, so we are getting there. Okay, so student, module, course. Okay, they even included assessment. Assessment, but it's okay. But the major one are 3. No, it's coming. Wait for you. So this can also be done with a bottom-up approach. Actually, this one is called a bottom-up approach, where you can start with the entities, then entities, attributes, then relationship, then the relationship. So this can also, for now, we are using a top-down. By the way, starting with entities is called a top-down, but there's also a bottom-up where we can start with attributes. You start with attributes, then you identify the entities. Then there will be an exercise as part of the self-study. Okay, do we have questions? Do you have any questions?
No, but I accumulated something which next time when we meet, I just wanted to do a practical thing, and then I wanted to compare some other.
Oh yeah, that's true, because
because
you know, database is a practical thing. Very soon we'll start